There are basically two ways in which we place information into hash tables. This is basically open hashing and closed hashing. We will take a look at those. There's some confusing terms here, so make sure that you're paying attention to these different methods. So I will begin by talking about separate chaining, which is also called open hashing. And this is called open hashing because the data is actually not stored in the table itself. So this particular hashing method stores the data in linked lists outside of the hash table. So the hash table contains pointers to linked lists, and rather than the data itself. So if I was declaring a particular hash table, I would declare a hash a table of, let's say, int pointers rather than actually ints. And so the items are hashed to a specific location, pretty much by the various methods that we've seen thus far. And then they're inserted into the linked list at that location. So in other words, if I'm looking at this table, there are 7 linked lists here. And when I go through the example, this will make more sense. So we've picked a prime number 7, and we have allocated our table. And we're going to insert the values 26, 13, 9, 4, 2, 7, 12, and 23 in that order into this hash table, which uses separate chaining or open hashing. So we begin, and we will use the direct mod hash function to just keep things simple. So we begin by looking at value 26, and we take a look at value 26, and 26 mod 7 gives me a remainder of 5, and so we insert 26 at the head of that linked list. All the other linked lists are empty. We then take the value 13 and we mod that by the table size M, which is 7 in this case, and the remainder is 6. And so we store 13 into location 6. Notice that there is no similarity between the data we're storing and the actual location where we're storing it. We then take the value 9, mod by 7, that is going to go into location 2. And we take the value 4, mod that by 7, and that gives us 4. So that maps out, and so far we have no problems. We've got 3 empty spots and we've had no collisions. And we're now going to add the value 2. So 2 mod 7 is not 5, it's 2. And so lo and behold, there's already an entity hashed to location 2, and so we have to add the value 2 to the linked list that's anchored at element 2 of the table. Okay, so now that linked list has 2 data items. It has the value 9 and the value 2. We then take 7. Okay, so 7 will hash to location 0 because 7 mod 7 is 0. We take the value 12. 12 mod 7 is 5. And so we have to extend that particular linked list by adding 12 to the end of it. And finally, we hash the value 23, and that extends the linked list that is anchored at element 2 of the table. And so separate chaining then, to sort of recap, we're storing the data outside of the table itself. And the collision resolution policy in this case is to simply extend the linked list at that location by adding the value. So we had multiple collisions. We had 3 collisions in this particular case. And for instance, the value 2 is a collision, and it clashed with 9. And then we got the value 12 was also a collision. And so those reside in the same location. And finally, the value 13 collided with both 9 and 2. I'm sorry, the value 23, not 13, collided with both 9 and 2, and is residing in the same linked list as those other 2 values.